Kaku reveals insight into a surprising revelation. The James Webb Space Telescope has recognized a disturbing signal transmitting from the Andromeda galaxy. For over a century, our understanding of Andromeda was generally terrestrial, but now, outfitted with the James Webb Space Telescope, our perspectives are decisively shifting. This new information has sent shockwaves through established researchers. However, what does this stunning revelation tell us? And why is it creating such a ruckus among space experts? Join us as we delve into the subtleties of this disclosure and explore how it affects our understanding of our adjoining universe. Before diving into the details of the disturbing signal, it is significant to understand some context about the Andromeda galaxy. Historically, Andromeda was the first hint that our universe extends beyond the Milky Way, shifting our understanding by highlighting that we may be just a small piece of a vast universe. Initially, the Milky Way was seen as the whole of the universe. Early cosmologists using limited technology could not separate the Milky Way into individual stars. This changed with Galileo Galilei in the 17th century. Using a telescope, he found that the Milky Way comprised numerous stars, challenging the idea that it was the universe's only world. The real game-changer came with Edwin Hubble during the 1920s. Using the Hubble telescope, he noticed distant objects beyond the Milky Way, identifying these as separate galaxies and expanding our view of the universe. One of these galaxies was Andromeda, also known as M31. Its observation dates back to the Persian astronomer Abd al-Rahman al-Sufi in the 10th century, who noted it without the aid of telescopic technology. By the 20th century, technological advancements allowed astronomers to explore further, revealing that Andromeda was an indistinct cloud with a vast universe of stars similar to our Milky Way but located around 2.537 million light-years away. The study of Andromeda has evolved significantly since then, with observations shifting from ground-based telescopes to space observatories like Hubble and now the James Webb Space Telescope. Each new instrument has brought us closer to understanding Andromeda's real essence. Deciphering Andromeda's design and organization helps astronomers delve deeper into the universe. It serves as a benchmark for our Milky Way, offering insights into system development and evolution. The relationship between the two galaxies is crucial for understanding the fate of our Milky Way, especially since they are expected to collide in around 4 billion years. Recently, the James Webb Telescope received a disturbing signal from the Andromeda galaxy. What does this latest signal tell us? The James Webb Telescope has brought new insights. This exceptional instrument, infinitely better than its predecessors, has captured data from Andromeda that challenges previous understandings. The telescope's robust sensors have detected unusual activity in Andromeda's center, varying significantly from past observations, intriguing scientists worldwide. The signal suggests vital processes happening inside the galaxy, potentially linked with its truly massive black hole or previously concealed anomalies. One key finding is the change in Andromeda's mass. Earlier estimates suggested Andromeda was significantly larger than the Milky Way. However, new data suggests this gap may not be as vast as previously thought. Updated measurements indicate that Andromeda and the Milky Way are more comparable in size, reshaping how we might interpret our galaxy's place. Additionally, the James Webb Telescope has provided clear images and spectra from Andromeda, revealing new star formations and chemical compositions within the galaxy. Such details are crucial for understanding how galaxies evolve and what conditions could lead to life. Another significant discovery involves Andromeda's active cosmic core. The data shows that the black hole at the center is more active than previously believed. This activity affects the surrounding region and may influence the galaxy's overall structure and future. The telescope findings also touch on the mysterious dark matter. By studying the gravitational effects on Andromeda's stars, researchers can better understand how dark matter is distributed throughout the universe. This is essential to addressing one of cosmology's biggest mysteries. What is dark matter, and how does it affect the universe? These new discoveries by the James Webb Telescope have led to various studies. Scientists worldwide are analyzing the data to uncover more about Andromeda's secrets. Each finding helps piece together the galaxy's history and future, providing a clearer understanding of the universe's workings. Andromeda, our nearest cosmic neighbor, has a variety of unique features that interest astronomers and set it apart from other galaxies. Firstly, Andromeda's size is significant. While estimates have changed, recent data suggests it spans around 220,000 light-years in diameter, making it one of the largest galaxies in the local group, much larger than the Milky Way. Its immense size contributes to its mass, holding an estimated 1 trillion stars, surpassing the number in our own galaxy. Andromeda's structure is another point of interest. It has a typical spiral shape but with a bulge. The galaxy contains a bulging center surrounded by rings of dust and gas, which are sites of active star formation. These features indicate a vibrant galaxy with ongoing processes that shape its appearance and evolution. The core of Andromeda is particularly interesting due to the presence of a double-capped outflow, suggesting it may harbor a very large black hole. This is similar to the Milky Way, but the nature and activity level of Andromeda's black hole provide valuable information for understanding these space objects. Additionally, Andromeda is surrounded by a corona of celestial material extending hundreds of thousands of light-years. This corona is composed of stars, planetary nebulae, and globular clusters, providing evidence of the galaxy's complex evolution and history. The globular clusters, in particular, are of significant interest. With more than 460 identified, they offer insights into the early stages of the universe's development and the dynamics of star clusters. Another unique aspect of Andromeda is its satellite galaxies. More than 20 smaller galaxies orbit Andromeda, some of which are being tidally stripped of their stars and gas, contributing to Andromeda's growth. This process, known as galactic cannibalism, highlights the aggressive nature of galaxy evolution and provides a live example of how galaxies grow and interact over time. But how is the Andromeda galaxy evolving, and what does its future hold? The evolution and future of the Andromeda galaxy are subjects of significant interest and research in astronomy. One significant aspect of Andromeda's evolution is its potential transition from a spiral to a ring galaxy. Observations suggest changes in the pattern could lead to this rare structure. Ring galaxies are rare and form under specific conditions, often after a collision or near-miss with another galaxy. If Andromeda is evolving into this structure, it indicates a history involving interactions with other galaxies. Andromeda's future is closely tied to its interaction with the Milky Way. Estimates predict that in around 4 billion years, Andromeda and the Milky Way will collide and merge. This event, while seemingly catastrophic, is a natural part of cosmic evolution. The collision will not involve direct collisions between stars due to the vast distances between them. However, the gravitational forces will reshape both galaxies during the merger. Gas and dust from both galaxies will interact, leading to new bursts of star formation. This burst of celestial creation will illuminate the merging galaxies, creating a unique and spectacular cosmic event. The collision between the Milky Way and the Andromeda galaxy will ultimately result in a single elliptical galaxy, a phenomenon common throughout the universe's history. However, it is unique in human terms because our direct involvement or experience with such an event is highly unlikely. These galactic collisions have occurred countless times in the cosmos, contributing to the rich tapestry of galaxy evolution. Despite this commonality, the prospect of our own galaxy undergoing such a transformation holds a particular fascination for astronomers and the general public alike. As the two galaxies merge, their central black holes, both of which are very large, will also eventually combine. The Milky Way's supermassive black hole, known as Sagittarius A*, and Andromeda's central black hole will be drawn together through a complex dance governed by gravitational forces. Over time, these black holes will spiral closer and closer, losing energy through gravitational wave emissions and interacting with the stars and gas in their vicinity. When they finally merge, the event is expected to release an enormous amount of energy, predominantly in the form of gravitational waves. These waves ripple through the fabric of spacetime, providing potential observable effects that could be detected by future instruments. This merging process will be marked by significant emissions of radiation. As the black holes draw closer, they will attract vast amounts of gas, dust, and stellar material. This matter, as it falls into the gravitational well of the black holes, will be accelerated to incredibly high velocities, heating up and emitting intense radiation across the electromagnetic spectrum. This process, known as accretion, can produce some of the brightest sources of light in the universe, such as quasars. Observing these emissions will offer scientists a unique window into the dynamics of black hole interactions and the conditions in the dense regions of merging galaxies. Focusing on this process provides crucial insights into the life cycles of galaxies. Galaxy mergers are a fundamental aspect of galaxy formation and evolution. When two galaxies collide, their stars generally pass by each other without direct collisions due to the vast spaces between them. However, the gravitational interactions can cause significant distortions in the galaxy shapes, triggering waves of star formation as gas clouds collide and compress. This starburst activity is a hallmark of merging galaxies and plays a critical role in shaping their future evolution. The role of black holes in this context is also pivotal. Supermassive black holes are believed to exist at the centers of most, if not all, large galaxies. Their interactions during mergers can have profound effects on their host galaxies. The energy released during the merger of supermassive black holes can drive powerful outflows of gas, which can regulate star formation by either triggering new starbursts or blowing out the gas needed for star formation, thereby quenching it. This feedback mechanism is essential for understanding how galaxies evolve over cosmic timescales. Moreover, studying the merging of black holes within galaxies like the Milky Way and Andromeda can enhance our understanding of gravitational waves. The waves generated by such mergers are incredibly faint by the time they reach Earth, but future gravitational wave observatories will be better equipped to detect them. These observations will provide direct evidence of the merging process and offer a new way to study the universe, complementing traditional electromagnetic observations. In essence, the eventual collision and merger of the Milky Way and Andromeda galaxy will not only reshape our local cosmic neighborhood, but also provide an extraordinary opportunity to study the processes that govern galaxy formation and evolution. By observing the merger and its aftermath, astronomers can gain deeper insights into the dynamic interactions that shape the universe, the life cycles of galaxies, and the powerful role of supermassive black holes in these grand cosmic events. What does the future of Andromeda and its expected merger with the Milky Way mean for the fate of our local planetary group? While it is unlikely that the planetary group will be destroyed, its position and conditions could significantly change. This includes potential shifts in orbit or even expulsion from the newly formed system. Understanding these processes helps scientists predict the outcomes of similar events elsewhere and provides context for the possible fate of our planet. The study of Andromeda's evolution and future is about understanding the forces at play and the inevitable evolution of galaxies over billions of years. The expected merger between our galaxy and Andromeda raises significant questions about its impact on Earth's environment. It is essential to understand that the vast distances between stars mean that actual star-on-star impacts are unlikely. However, the gravitational effects of such a merger would be significant. The merger could disrupt the stable orbits of stars and potentially send many of them, including our Sun, into new trajectories. This change in position could have significant implications for Earth's climate. If Earth's distance from the Sun changes significantly, it could either heat up or cool down, depending on the direction of the change. A warmer climate could lead to melting ice caps and rising sea levels, while a cooler climate could trigger a new ice age. Additionally, the merger could lead to increased radiation reaching Earth. As the Milky Way and Andromeda's black holes approach each other, their interactions could accelerate particles to high energies, increasing the amount of cosmic radiation entering Earth's atmosphere. This increase in radiation could have detrimental effects on Earth's ecosystems, potentially leading to increased mutation rates in organisms and impacting biodiversity. Changes in Earth's orbit or axis could also disrupt the distribution of ecosystems across the globe. Species adapted to specific climate zones could find their habitats unsuitable, leading to shifts in biodiversity and ecosystem structures. Some species could thrive under these new conditions, while others could face extinction. Furthermore, the merger may trigger new star formation as gas clouds from both galaxies collide and compress. If this star formation occurs near the planetary system, the radiation from these new stars could impact Earth, possibly leading to increased levels of ultraviolet radiation reaching the surface and affecting living organisms. While these changes are speculative, they are based on our understanding of cosmic interactions. The merger of the Milky Way and Andromeda provides a unique opportunity to study these processes in real time, enhancing our understanding of galaxy evolution and its potential impacts on planetary systems. In conclusion, the discovery of the disturbing signal from the Andromeda Galaxy, as revealed by the James Webb Space Telescope, has opened new avenues of exploration and understanding. Andromeda's fascinating features, evolutionary trajectory, and impending merger with the Milky Way offer valuable insights into galaxy evolution and the cosmic dance of celestial bodies. The potential impact on our planetary group and the broader universe highlights the interconnectedness of cosmic events and the ongoing quest for knowledge in the field of astronomy.